Hey, welcome back. We're going to take a look at another polar equations battleship game. And in this case, we're not plotting points, we're plotting whole functions, which is really fun. So in this case, we can see with the terms set up the way they are, we have some stretching, some shifting. Let's take a look. So this is your basic sine function. And we can see it down here with our equation. And it's not going to hit any of these points. It's not very close to it. We could make that bigger by changing the leading term here. And that will make all of these terms twice as large, but they're never going to come down here on this end of the spectrum. So question is, what could we do about it to get down to here? And there's a couple of things that we could do. We could rotate this a little bit, and that's what the C term does for us. So if I change that term to say 2, this circle is going to rotate. And we can see here that it's been rotated and it's over here now. But if we want to hit these points, it looks like we're going to have to rotate some more. Let's try 3. And we got real close to hitting a point, but didn't quite get there. Let's try 3.25 and see if that hits a point. And it did. And in this way, we can start to experiment with how polar transformations influence where the polar functions appear. Let's try to hit another point, and let's take a look at a different type of polar equation. We were just looking at a circle made with a sine function, but we could just as easily look at a polar rose. So let's do that. I changed the B term here, and you can see it updating. And we can see from the petals of our rose, we're not going to hit this point. In order to hit this point, they're going to have to be bigger. So we can change our leading term over here and make our petals bigger. So those petals are now big enough to hit a point, but they need to be rotated to make it over there. So let's rotate it again, and let's try 2. And we hit one of the points. So this is an example of looking at a polar rose where we've added 2 different types of transformations. We've rotated the rose, and we've done a vertical transformation by making it larger. To get that final point, what we might want to do is just make our rose smaller. And let's see if that can get us in on that point. Oh, we're really close, but we're not quite there. Let's try 2.25. And we hit it. So the whole point of this particular simulation, this game, however you want to think about it, is to use transformations of polar equations with our battleship game to try to get a better understanding of how they all work together in polar space.